Hello everyone, today I'm going to introduce the second part of the anaerobic digestion model number 1. Last time we talked about the mass balance of anaerobic digester and how we can do the mass balance for each state component in the liquid. And we said that the accumulation is the part that is coming from the influent minus the part that comes out of the effluent or from the digester, plus the processes or the conversions that happen inside the digester itself. And we simplify this into this kind of simple form. It's the same thing actually here, but yeah, we just combine some parameters, especially for the flow and the volume of the liquid. Basically, these two parts are constant, so basically we just have them factored out of this quantity. And then today is just to concentrate on the metrics of these equations and how can we read the table basically for the metrics of different rates and different equations. And here, this is the table from this a publication that has the model in details, but yeah, just this is the table A3. This basically presents the biochemical rate coefficient and the kinetic equations for 12 component, 1 to 12, and for 19 processes. So if we look at here, you will have 19 processes ranging from disintegration, hydrolysis of carbohydrate, hydrolysis of protein, and so on and so forth, until decay of different bacteria or archaea in the system. And then we have the component here, just something like 1 to 12, again, ranging from monosaccharides, amino acids, and long chain fatty acids. So basically, this SCU, this is monosaccharide, and SCAA, this is the amino acids, and SFA, this is long chain fatty acids. The next table that also presented in this publication, they have also the same processes, basically 1 to 19 process, and the components that ranging from 13 to 24, and this again, this is XC, this is composites, and X carbohydrates, and XCH, and XBR, this is protein, and so forth. How to read this one? Just for a reminder that there was some typo here. This was in the publication, but this should be FFALI, not 1 minus. So basically this to delete 1 minus here. So basically the value should be FFALI. Okay, how to do this one? So basically, if we would like to go to do the mass balance for monosaccharides, basically we have the hydrolysis of carbohydrate, this part that actually add monosaccharides to the system. This means that the sign should be positive. And also hydrolysis of lipid, part of the lipids will be hydrolyzed into long chain fatty acids, which is this part, FFALI, and part also will be hydrolyzed into the liposaccharides, like the what they call it, the hydrolysis of lipids is this good part for long chain fatty acids and for glycerol or glyceride. So this is basically the monosaccharide, this is part here. And also part of this monosaccharides is going to for the uptake. So which means that we have a negative sign here. So in this case, if we would like to go to read this, it will be part, basically 2 parts to add more to monosaccharide and 1 part to take to the to uptake. In this case, we will have two equations with positive signs for the rate equations, which will be hydrolysis of carbohydrate. So basically 1 times the K hydrolysis CHCH, XCH, and the other one is 1 minus FFALI, and times the hydrolysis of the lipids here. And then 1 for the uptake will be minus, because basically this will be taken out. So basically the concentration will go down. And this is the rate for the sugar uptake, the equation for the rate for it. So in this case, if we would like to write the equation now, this is basically the previous equation, that the general equation for the mass balance. And here we have two processes, one ρ2 and one ρ4 times the coefficient of the changes or for the rates, and one for the uptake will be minus, which is ρ5. So again, this is the value that just from the other table. So ρ2 is K hydrolysis CH times the XCH, and the ρ3 for the hydrolysis of protein, and ρ5 for the uptake of sugars. Again, this also the same thing for amino acids or for long chain fatty acids. The same thing basically here. If we would like to go for amino acids as another example, so we'll have amino acids here. So we'll have two component or two equations for one for adding more, which come from the hydrolysis of protein. So basically the concentration will increase. This is why you have positive here, and one for the negative, which will be uptaking this part from the amino acids to other intermediate like VFAs or long chain fatty acid, and so on and so forth. Okay, so and then you can actually just write the different, actually maybe 24 equations or more to have the entire model. And yeah, so basically also the same thing actually here for long chain fatty acids and so on and so forth. With that, I hope it's actually useful for you, and see you next time. Bye bye.